Hello guys, today I'll show you how to build an app using LLM. Now we'll not be deploying this LLM in any cloud. I'll have a separate video for that. But this LLM, I'm using this technique called RAG. We are not fine tuning or nor we are training it from scratch. We'll be using retrieval augmented generation, wherein what we'll do is rather than fine tuning it, we'll have the model run in our local, that is CPU, in our laptop. And once we have a data, for example, let's say that you have a source data set and you have questions on those, in that data set that you have as source, and any question that you ask, what the model would do is it will take the context from that original data set, and based on your query, it's going to retrieve the most similar chunk from that document, use your query, and the chunk that it took from that document as a context, it'll be able to respond to your query. For example, let's say that I have uh, a document wherein the document talks about the different cases that happen between government and individual, right? For example, let's say that I ask a query saying that I need the details of the cases that happened between individual X and government of Tamil Nadu in the year of 1997. It's going to go to that document, source document. It is going to take the most relevant chunk from that document with your query as prompt, and with that chunk as your context, right? Prompt and then context, both of these will be sent to the model, and the model will be able to answer your prompt based on that context. And it can tell you details like, yes, there happened a case in 1997 between individual X and government of Tamil Nadu on this issue based on the document that you provided. So it has a lot of applications in real world, wherein the inference is also going to be quicker, because it basically doesn't require any training at all, zero training at all here. So I'm using Fire's vector DB here. Again, you can also use Fire's or any other vector DB for that matter, and it's your preference completely, and this would run in CPU. And so I'm also running using an open source, right, a framework called Chainlit for a UI, right? It's going to have a UI which is very similar to ChatGPT, right? So I'll show you a demo of the application. What I've done is I've basically created a CricketGosipper app, right? I'll show you the data that I used. So if you go to data, right, and then yeah, I've used two data source. You can see International Journal of Sports and Society, not just cricket, February 2013, and Jubilee Book of Cricket. So any prompt that you ask or give to the model, it's going to take the relevant chunk from both of these PDFs, right, or the original data source, and based on that chunk, it got from these two documents. That will be used as a context, and your query will be used as a prompt. And the model will be able to answer any questions that best fits your query, right, your input query. And if you come here, right, the model that I've used is Llama 2 7 billion chat, and you can find this in Hugging Face. So again, it's open sourced by Bloke. Thanks to him. Right. So you can see that I'm using something called C transformers, which is basically would have, I guess, C++ binding, and of course it supports Python API to connect with it. And this is basically the page. The code and the link and the video that I'm making, it will be part of this GitHub repository, and it is public. So feel free to contribute or raise issues, right? I'll make sure that I address it as quickly as possible. All right, I'll basically show you the demo of the app. Just give me a moment. So So this is how you run it. You can see this is the command chainlet run model.py and then w. So this is going to invoke an app. Now it's going to take some time when I send a query, right? It's going to send, I mean, take some time because again I'm doing this in my CPU, and running this in CPU, it's pretty laborious. And you can see that this is actually a README file that you can edit, so that folks would understand how to run this and what is the description of this application. You can see this is a CricketGosipper application, and if you have anything controversial that you can ask, it will be able to answer it regarding cricket, right? And maybe let's get going. For example, let's say that I ask something like, do you have any reference of match fixing? One second. Yeah, you can see it's going to basically give you the process, right? It's using retrieval QA, using stuff documentation chain. Everything is part of the code. I've commented it. You can go through the code, and it's using LLM chain, and it's using C transformers, like I said, transformers with C++ binding, right? You can see it's running, but you can see the entire process, right, of what's happening. Where is our current um, prompt, right? How is it being processed in this entire pipeline? So this is the best thing that could happen when you're building the application. You just doesn't. I mean, you don't have to just sit idle looking at the screen. You would exactly know what is the exact phase. Your pipeline, right, exact phase of the pipeline where the current processing is happening, right? And having said that, while it is processing, let me explain you the vector db. So this is basically how I've constructed it. You give it a prompt. You have the original data set, right? You have the original data set. You have document 1 and you have document 2, right? What I've basically done is I've converted this into a vector database using fires, right? So the entire document is going to be converted into an embedding, a vector embedding, right? Zero, zero, one, 002, so on and so forth. And it's going to be there, right? It's going to have the entire document embedded, right? With numbers, right? With numbers, with integers, with numbers, right? So not integers, sorry, numbers, right? And what happens is, let's say that I give a prompt, just like how I did it. Can you give me any reference of match fixing, right? That's query 1, right? What happens is this is again going to get converted into an embedding, right? Similar to this embedding, right? And from this document embedding, it is going to give me the most similar chunk of embedding from this vector db. And this will be used as a context. The most relevant document will be used as a context, and the input query as prompt, right? Prompt. And both of these will be given to the model, and with this prompt it will be able to identify how to respond back, saying that yes, there are reference with respect to match fixing, right, in the year, so on and so forth. I'm expecting something similar, right, in similar lines. But basically this is how uh, the application works, that I'm showing you right now. Now if you are wondering, right, so let's say that I have a query and I have all the embeddings stored in my vector db. So it's going to basically have to calculate similarity with every embedding that it would find in the vector db. For example, let's say it has 100 million embedding. I'm just making it up, right? 100 million embeddings in it. And if you are having a prompt like this, it has to calculate similarity score 100 million times. right? So it's a lot of resource, and it's also going to consume a lot of time that way, right? So which is not very efficient. So what folks have done is they have indexed this vector db, right? They've further reduced them into indexes. And when you send a query, let's say that this 100 million is having indexes, 100 indexes, right? According to your prompt, it's first going to choose what is going to be the relevant index, and it is only going to run the similarity in that index. Let's say that the first index is most relevant to the prompt that you have sent. It is only going to run the similarity in that index. Now I'll not go into the detail of how it is indexed. That's for another session. But anyways, I'll include some materials in the video description so that you can go through it and understand how this vector index would happen and how is it reducing the search space when you're calculating the vector dv similarity score. There are lots and lots of similarity scores that you can configure: Euclidean, cosine similarity. You can configure a variety of distance metric that you would want, which you deem fit to your application. But that's up to you, right? Which whatever would work for you. But generally, cosine similarity, is generally preferred, right? Or I would say, rather than I would say preferred, it's widely used when they are calculating similarity between documents. And opposite documents, when there's no connection at all, it's going to be orthogonal. When I say orthogonal, it's going to be 90 degrees, that is pointing in opposite direction. Let's say this is d1 and this is d2, right? So if it has zero relevance or very little relevance, it's going to be orthogonal to each other. But that's basically how vector db would work. Now let's see what the prompt has to say. Yeah, you can see that it has responded, right? Yeah, you can see, yes, there are several references to match fixing in cricket history. For example, in 1876, a match between Oxford and Cambridge was reported to have been fixed, right? And you can basically see what is what, right? What is the response here? And the best part is it is actually pointing you to the source on the document. You can see document page content, fragilities and instabilities, and you can see document page content and match down to 1862. And you can see that with the recent conviction of two cricketers in spot fixing case in England, and reports of the semi-final match between India and Pakistan in the 2011 World Cup being fixed, Sports Illustrated India, it's basically showing you which page to look at, not just cricket. Feb 2013 PDF, page number 7, right? So yeah, I mean, this is basically the response, right? Several references to match fixing in cricket history. For example, in 1876, a match between Oxford and Cambridge was reported to have been fixed. Additionally, there have been multiple instances of spot fixing in modern cricket, including the conviction of two cricketers in 2019. So it is responding relevant to your question. And this is basically how the app would look, right? So this is what I wanted to show you. And in the next video, I'll basically tell you how to deploy this in cloud. Now, this has several applications to it, right? Application would include, for example, let's say you are auditing an insurance policy, right? And you have lots and lots of doubts, right? You could, let's say that you're auditing a healthcare insurance policy, and you could have lots of doubts when you're auditing a claim, and you have all the knowledge base stored somewhere. What you could do is you could just chat with that knowledge store. For example, let's say that you are not sure about how to see if a particular condition would fall under a claim policy. You could ask the knowledge base. For example, if you want to know if plastic surgery, right, or any cosmetic surgery would fall in a particular policy group, you could basically query the knowledge base, describing the process, procedure, and the condition, and it will be able to respond to you saying that this particular policy number does or does not support a procedure that you originally prompted. This is one use case. The second use case could be, you could have your product, right, knowledge base stored somewhere in a vector db, and you could have a model like this wherein folks can understand your product more, understand the features of your product more. And let's say that you want to give someone knowledge transfer on a particular product that you guys are working on, rather than someone sitting with you, right, they can very well query the knowledge base to understand more about your products. So these are some of the use case among several that you could leverage rack technique for, right. Again, right, this is not that intensive. You can see that it is running in my cpu, it is not gpu, right. So hence it took some time, but you can see that it's pretty lightweight, right. And the model, I guess it's somewhere around 7 or 8 gb. And I would recommend you to run this model in your local if you have at least 16 gb of ram and not lesser, because your machine would struggle if you're doing it. But that's about it. Like I said, right, the code, the link to model file, and the video, and then how vector db works, right, and how indexing happens in vector db, everything will be part of the youtube video description. I would I would request you to encourage me more. If you like this video, please do share and comment. Thank you.